This is going to be a video explanation for our quiz review in our packet. This way, if you're doing it at home and you're stuck, you need explanation, it's here. If you just want to check out your answers, you can go to Canvas. There's a PDF of just the answers as well. All right, let's get to it. The first one is a parabola. It says, given the standard form of a parabola, find these things at graph. So HK is going to be my center, and it's always opposite. So since I have an x minus 1 in parentheses, I'm going to do the opposite of minus 1, which is positive 1. And you'll notice there's no parentheses for the y, whereas if you look at B, the y does have parentheses. So because there's no parentheses, there's no shift in y, which means I've centered at 0 in terms of y. So 1, 0 is this point right here, and that's going to be my vertex. So I'm just going to give that a label of T. So the next thing that I'm going to look at is my focal length and width, and that's going to help me get that focus. So my focal width is the coefficient of that term on the right-hand side. So you don't have to do any work for the focal width, it's just that 12. The focal length, though, is 4p, okay? 4p is the 12. So that number on the other side, we're setting that equal to the equation 4p. That's just from the formula of a parabola. And if we solve for p, we end up getting 3. So the focal length is 3. Here's what that means for this parabola. The focal length is going to tell me where the focus is. So I'm going to go 3 units from the vertex, but there's 4 different places I could go. I could go 3 units up, 3 units left, 3 units right, 3 units down. So how do I know which way I go? I look at the original equation. What's being squared is x. So you're used to like y equals x squared being your traditional parabola, your u or your upside down u. So this is going to be one of those because x is squared. Now if you look on the right hand side, because the coefficient of y is positive, it's going to open in the positive direction. So this is going to open up, which means the focal length is going to go in the up direction. So I am going to go 3 units up from my vertex. That point right there is my focus. This distance right here is my focal length. Right, I went up 3. Now my focal width is 12. That's how wide my graph is going to be at the focus. Because a parabola is symmetrical, I want to distribute that 12 evenly, which is 6 and 6. So I'm going to go 6 from the focus, because it's a focal width. I'm going to go 6 to the right and make a point, and 6 to the left and make a point. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This distance here is my focal width. If you counted the blocks, there would be 12 of them. So at this point, we can technically graph the parabola. So the parabola is going to go through the focus. So this is a focal width point and a focal width point. So my graph itself is going to go through the vertex and the focal width points. And it looks like that. The last part of the graph that we add is called the directrix. The directrix is like a boundary line. It doesn't go through the graph. And so I'm still going to use that focal length to get it because everything about a parabola is symmetrical. So instead of going up 3 for the directrix, I'm going to go down 3. So from that point at 0, I'm going to make a point here. Now the directrix itself is not a point, it's a line. And we like to make the line dashed, showing like it's not really a line on the graph. Like you wouldn't see it if you graphed this one. It's just a boundary line. So it looks like that. Now a horizontal line in math is a y equals equation. So I'm going to make this a y equals, and then this is going through -3. I'm noticing that I didn't write the coordinate of the focus though. So where I made that F, I went over 1 and up 3. That's the coordinate of that focus. And then I'm going to label this D for directrix. Now looking at this next one, the center is HK. With the X is a +3, so I'll do -3. and with the y is a -2, so I'll do +2. So I'm going -3, +2, and I'm gonna label that my vertex. Now I need to find what's called my focal length and focal width. My focal width is easy. It's just what is the coefficient. Now, a width doesn't make sense to be negative, so I'm just gonna call the focal width 4. And then I'm gonna solve the focal length by doing 4p equals that focal width value. And if I divide by 1, I get that if I divide by 4, I get that the p value is 1. So the focal length is 1. Again, it doesn't make sense for us to call a length negative, so I'm just gonna put a 1 there. What the negative does is give me direction though. So the fact that it's negative means it's either gonna go down or to the left, because those are my two negative directions. So how do I know which one it is? Well, if you look at the equation, this is a y squared. We're used to parabolas being x squareds. And parabolas that are x squareds open up and down. So because it's the y squared, it's gonna be left or right. And because it is negative, we're gonna make this one go left. So when I graph my focal length, I'm gonna go to the left one of my vertex. And that puts me right there, and that's called my focus. And so that is the coordinate point. It looks like -4, 2. From the focus, I'm gonna do my focal width, but because this is opening wide, I'm gonna go up and down the width rather than left and right. So I need to split the width up 4 evenly. So I'm gonna go 2 up and 2 down. And at this point, I know it's gonna open left because it's that negative value, and now that I have my focal width values, I can do that. So you see the focal widths go in line with the focus, okay? And it just depends on which way they open. Now the final thing I have to do here is the directrix. So since we went left 1 for the focus, we're gonna go right 1 for the directrix. And remember, the directrix, we don't want to go through the graph, so I'm not gonna make this one horizontal. To avoid it going through the graph, I'm gonna make it go up and down. This is a vertical line. In math, vertical line are x equals equations, and this is going through x equals -2. So that's my answer for the first 2 of these here. The next section says, given the standard form of the circle, find the center radius. So now I'm looking at a circle. The center for a circle is pretty similar to the center of a parabola though. Opposite of x, opposite of y. So since x was +3, I make my center -3. Since y was -3, I make my center +3. The radius is going to be the square root of that number on the right, which in this case is a 7. So here's what that means for my graph. I'm going to make a point at -3, +3, and that's my center. To make a radius of 7, I need to go up 7, over 7, left 7, right 7. A circle is distributed evenly. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm just counting. So that this distance here is 7, this distance here is 7, this distance here is 7, and this distance here is 7. The radius all around the circle then is 7. And now I can just connect my outside points as best I can to create that circle image. For the next one, you'll notice there's nothing with the x. There's no parentheses, which means the x is not shifted. My center is at 0. Opposite of -5 is +5. My radius is going to be the square root of 20. Now normally we would simplify that to √4, √5, which is 2√5. So the true unrounded radius of this is 2√5. When I go to graph that though, I'm going to round it so I can estimate. So I want you to write the 2√5 on your quiz, And you can also write the estimated value as well if that helps you graph, but you do still need, like this is the actual radius of the graph. So I'm gonna make my center at 0.5, and then I'm gonna estimate about 4.5 up, down, left, right. So 1, 2, 3, 4.5. And then I just connect the outside points to make my circle. That's not great, but you guys get the idea. The next part of the review guide is using the complete the square method. The first thing I notice about A is it's definitely a parabola. The reason I know it's a parabola is because there's only one squared term. So when we are completing the square with the parabola, we're only going to complete the square once because there's only one square term. In the standard form of a parabola, x and y are on different sides. So what I'm going to do first, that's my blank for when I complete the square. But what I'm going to do first is I'm going to move the 10y to the other side. So I'm going to subtract it, and the plus 1 to the other side. So I'm going to add it, and then I'm also going to add my plus blank space. Because remember, when we complete the square on one side, we have to do the same thing to the other side. So this blank is going to be half the middle number, so half of 6. Squared. So half of 6 is 3, 3 squared is 9. So this number I am adding in is 9, but I got to make sure I do that over here too. So if I factor this, what multiplies to 9 and adds to 6, it's 3 and 3, or x plus 3 squared. We've completed the square. Over here, I've got negative 10y, and when I combine my like terms 1 and 9, I get 10. In a parabola, though, we want parentheses on the right-hand side, too. We're just not completing the square here. We're factoring, but we're factoring a GCF. So the GCF between these two terms is negative 10. So I'm going to divide a negative 10 out. So negative 10y divided by negative 10 is just y, and positive 10 divided by negative 10 is minus 1. This is the standard form of my parabola. From here, I could tell you a lot of things. I could tell you the center is negative 3, 1. I can tell you that it opens down because it's x squared and there's a negative coefficient. And then from there, I could tell you that the focal width is negative, or is 10. And then I could solve for the focal length and get all of the other things from that. All right, letter B here. This is a circle because I have 2 squared terms. So I'm going to rearrange here a bit. I'm going to have to complete the square for x. I'm going to have to complete the square for y. And then that negative 4 is kind of out there on its own, or sorry, positive 4. I'm going to move it to the other side by subtracting it, and then I'm going to have to add 2 numbers to this as I'm going to complete the square twice. So my first blank is going to be half of negative 5, which is negative 2.5. And then I'm going to square that, which is 6.25. And then my second blank is going to be half of negative 6, which is negative 3. But when I square that, I get positive 9. Factoring with decimals is a little bit harder, but you can always memorize that this number that goes here in this parentheses is just half of the middle term. So it's going to be 5 over 2. I'm going to write that as 2.5. Because it's not a repeating decimal. If it was a repeating decimal, I'd have to keep it in fraction form. Factoring this one's a little easier. What multiplies to 9 and adds to negative 6? Y minus 3 and y minus 3, or y minus 3 squared. If I add the numbers on the right-hand side of the equation, I end up with 11.25. This is the standard form of a circle. I can tell you that the center of the circle is 2.53. I can tell you that the radius of the circle is the square root of 11.25. And then from there I could graph it. This one in part C is a circle because I have 2 squared terms. So I'm going to have to complete the square twice. Actually, I'm not going to have to complete the square twice because there's no linear y term, which means this y term's not being shifted at all. So I'm just going to kind of leave the y squared on its own. I am going to subtract the positive 4 to the other side, though. You could put for the y squared plus 0x, but essentially you're just going to be adding a 0 to your equation, which doesn't do much. So this first blank is going to be my perfect square, so half of 8 is negative 8 is negative 4. Negative 4 squared is positive 16. So I want to make sure that I add that 16 to both sides of the equation. When I factor this, I get x minus 4, or x minus 4 squared, plus y squared, because I didn't have to do anything to that. And then over here, I've got 12. So the center of this circle is positive 4, 0, because y didn't shift. The radius of this circle is the square root of 12. This one over here, letter D, this is a circle. Here's what I'm going to do to this circle. I'm going to divide out a 4. So I don't have to worry about using those coefficients. All of these things are divisible by 4. So I divided a 4 from each of the terms. Now I'm going to just rearrange my order and add my blank for completing my square with x, and add my blank for completing my square with y, and then I'm going to add the 2 to the other side, and then I'm going to have 2 blanks over here for my complete the square numbers. Half of negative 4 is negative 2, 2 squared is 4. Half of 2 is 1, 1 squared is 1. So I'm adding a 4 and a 1 to this side of the equation. At this point, I can factor what multiplies to 4 and adds to negative 2, minus 2 and minus 2, or minus 2 squared. And then what multiplies to, it should be a plus, sorry. What multiplies to 1 and adds to 2, positive 1 and positive 1, or positive 1 squared. And then on this side of the equation, I have 7. So what this means is I have a circle with a center of 2, negative 1, that has a radius at the square root of 7. Last 2. This one's going to be a parabola. It's only got one squared term. In a parabola, x and y are on different sides of the equation. So I'm going to keep my squared term and leave a blank to complete the square. I'm going to bring the 8x to the other side by adding it, and the 40, and I think we changed this. I'm going to bring the 44 to the other side by subtracting it. The number in this blank is going to be half the middle term, negative 6, squared, 36. Now I can factor this side to y minus 6 squared. If I combine my like terms over here, negative 44 and positive 36, that's negative 8. I need my x to be in parentheses 2 so that I have an h and a k, which means I do have to factor the right-hand side, but it's not quadratic. So the only way to factor it is to do GCF. So I'm going to divide an 8 out from each of these. So I know that this is a parabola because it's got one square term. I know that the center is at positive 1, positive 6. I know that because y is squared, it's going to either open left or right, but because the 8 is positive, it's going to open right. Okay, I know that 8 is going to be how wide the graph is, and 2 is actually the focal length because I can divide that 8 by the 4p. Lots of things that you can tell from a parabola from standard form. So the last one only has one squared term. Again, another parabola, which means x and y are on different sides of the equation. So I'm bringing the x and the 28 to the other side, and because I'm moving it to the other side, I'm making it opposite. In this blank is going to be half of my middle term, so negative 5 squared, so 25. If I factor over here, I get y minus 5 squared. And if I combine like terms over here, I get negative x minus 3. Now I know I need parentheses on this right-hand side, so I have to factor something out. And since I notice they're both negative, I can divide a negative 1 out from each of them. So this is a parabola because it's one squared term. Its center is negative 3, positive 5. It's y squared, so I know it's gonna open either left or right, but because the coefficient on the other side's negative, it's gonna open left. I know that the width of the graph is only 1, so it's a really skinny parabola, and then the length would be 1 divided by 4. So again, also that's really short as well. Okay, hopefully that helps. Quiz tomorrow.